I'm going to take a brief pause just to make sure that it really is live. Welcome to another episode of In the Mood for HTTP. I have the traumatic news that Glenn will not be joining me today. We had a minor conflict, life happens and all those things, but considering I have topics that I want to talk about, we decided that we would see whether I can actually pull this off on my own. This will be somewhat challenging, but we will do our best. So, in lieu of Glenn being here in order to do his wonderful little story about Auth0, I would like to thank Auth0 for being a sponsor of this show. Auth0 Extend. I'm not even going to try and do the product. It's serverless. It's awesome. It allows you to embed serverless stuff into your SaaS product. And we're going to start off, just so that I can get things rolling, with a conversation about the bouncer pattern. This is sort of a continuation of the conversation we were having a little bit last week about having this idea of self-service APIs. And I'm just going to share my screen here. It's far more unusual actually having a conversation with just yourself as opposed to actually having a real conversation with somebody else. Share application window. There it is. Okay, so it says that I'm sharing, so hopefully you can see this. And for those of you who are listening on our podcast feed, which hopefully will be put up into iTunes fairly soon, we'll be describing it so you're not missing anything. I will include the links in the Twitter stream. So the bouncer pattern is a way of, it solves the problem of being able to do complex queries that are very difficult to fit into a query string. I mean, if you're making a regular request that you want to be able to query some data, usually you're able to put it parameters either in the path or the query string. Sometimes when the queries get rather complicated, like for example in a GraphQL query, or a SQL query for that matter, it's hard to encode all of that into the URI. So the idea is that we use a post request, and you post to a special resource, and you say, here's the query, and it returns back a redirect to another URL that takes all of the query parameters from the query that you've uploaded, and it kind of creates like a hash or a fingerprint of those queries and regenerates a new URL that you can then do a get from. The idea being is that because we're now doing a get, we can actually return caching headers, and we can get a complete cached response. And if other people then go and make the same request to that same set of query parameters, hopefully your fingerprint algorithm will generate the same fingerprint, and they will get potentially a cached result if it's still fresh, rather than having to re-execute the entire query. So it's kind of this combination of being able to support complex queries, but also being able to cache the results. And that is the bouncer pattern. And the one other little comment I add here is don't bookmark on the client that fingerprint URL, because there may be a desire to expire that stored, because that fingerprint has to refer to something that that is stored on the server side, and the server is going to want to expire that at some point or other. Yeah, you have to forgive me for giggling there. I just saw Seb's picture in the Slack channel. We do have a Slack channel for the In the Mood for HTTP. If you find our Twitter account, you'll find details of how to get to the Slack channel. And he has me on a wall, which is not intimidating at all. So I'm going to stop sharing, and we're going to continue on with this conversation. Me talking to my computer, free of Glenn adding his wisdom. So next topic, I tend to pick these topics based on just conversation that I've had over the week, and this is one that my dear friend Ron from the Open API Initiative and SmartBear started to bring up with me the other day. And it's the conversation of URLs and slashes in URLs, and or more specifically in the path part of the URL. Now, obviously the slashes in the regular path segments are not a problem at all. What people tend to have a problem with is the slashes at the end of the path and the slashes at the beginning of the path. And I see way too much code where people like creating and constructing URLs just by doing string concatenation, and they'll have little bits of code that says, oh, well, if there's a slash already there, then we won't add an extra slash. If there isn't one there, we'll just add one. Or at the end, this trailing slash on the end, we'll just chop that slash off. And the problem is that can lead to fairly inconsistent behavior. And ideally, you want to leave those slashes alone and make sure you use some kind of algorithm that's built into your platform that actually knows how to combine relative URLs properly, because there's a bunch of kind of iffy rules with regards to how to do relative URI resolution. And people often think, well, that slash on the end of the URL doesn't actually really mean anything, when in actual fact, it is significant. We're just led to believe that it isn't significant because web servers traditionally, if you access a path that in a file server hit just a folder, what it would do is it would go looking in that folder for resources with some common names, index.html, default.htm, HTML, depending on what platform you want. So web servers kind of got into this habit of pretending that, well, it didn't really matter whether you put a slash on the end or not. But the reality is they actually manipulate that URL before serving it to you. And if you have if you specify a base as like a relative, a base for creating relative addresses actually in your payload, then whether there is a slash on the end of the URL or not couldn't actually make a difference to how, well, it wouldn't if you specify the base, but because the base is explicit. But when you specify the base, it makes a big difference whether or not you put a slash on the end of the URL. And sort of the same goes for the slash at the beginning. And this is the conversation that I really need to have with Ron, because in the Open API format, we do something that I'm not a fan of, and that is we insist that every path, the key starts with a slash. It is a requirement that it starts with the path. Now, the thing is, if you have a relative URL that starts with a path, it means go all the way back up to the root, all the way back up to example.org, right? And it means that you can't host, or when you resolve that URL, it is not hosted at some relative place, it's hosted right up at the root. So in Open API, we actually have a base path. And the only way it works is if you take the base path and you glue it together with the actual path. And so therefore, for gluing that together, you can't use algorithms that do proper resolution, or it will just ignore that base path. So that's an inconsistent that I'm not a big fan of. Ron apparently has a reason why we do that, and I'm sure he's going to reveal it all to me, and we'll get it all sorted up and explained. So the moral of the story is have respect for those slashes at the beginning, at the end of your URL. They actually are significant, and don't ignore them. So moving on to the next topic. I've had a few conversations in the last week or two about HTTP caching, and I've seen a couple of blog posts. I'll put some links in the Twitter account about a blog post from a fairly senior person at Microsoft about caching, and talking about the dangers and the risks of doing caching yourself, because caching is hard, and it's absolutely true. It is difficult to implement caching. The thing is, I'm sort of guilty of this. I kind of use the term caching indiscriminately when really I always mean HTTP caching, because It's actually been defined really, really well, and there are standard implementations out there that do it. You don't have to re-implement yourself. The problem is a lot of people, when they think of caching, they think of, oh, well, what that really means is, so let's say I'm on the server side and I want to cache something, then I'll just create either an in-memory or file store, and I'll grab the response that I have and I'll just generate a key for it, and I will store it either in an in-memory array or will store it as a file on disk. And then if somebody asks me for the same thing again, I'll generate the key again, and then they'll use something like Redis or Memcached, which is nice back storage, but they've created a very simplistic caching mechanism with regards to just generating some key and doing a lookup of some key. And the opposite thing happens over on the client side. People say, well, you have to do caching. So they say, okay, well, on the client side, what I'll do is I'll get the resource I'll make an HTTP request, I'll get the response back, I'll deserialize it into my object, and then I'll cache it away somewhere on the client side with some primary key. And then I'll add some kind of repository layer so that when I'm going and making a lookup for this object in the future, before going off and making a network request, before formulating my HTTP request, I'll go and look in this dictionary and see whether it's already there. But to do that, I have to know, well, how long I'm going to keep it there, and what happens if the cache gets too big, and how do I start, expiring things out of the cache, and all of a sudden they have to start making all those decisions that are a little tricky, or for some reason, this particular request, I don't want to get it from the cache, so I need a way of bypassing the cache. So slowly they start having to increase all of the functionality around this kind of homegrown caching solution. And if instead of building these kind of, let's call them in-application caches, we say, okay, no, let's use an intermediary cache, an HTTP cache that sits as some intermediate, either in middleware in your client application, or middleware over on the app server side, or even an independent outer process thing like a Varnish or a Squid or an Nginx that sits out of process, but in between the client and the server. And then to start using the HTTP caching directives. Now, the big difference is in an HTTP caching environment, it's always the server, the owner of the resource, that defines the lifetime of the resource. So we have a cache control header that says max age, right? So, or you can use expires, but max age has some advantages to using it. So you say, well, this thing that I'm returning should be good for, I don't know, 30 seconds, right? It's not likely to get outdated in 30 seconds. And well, if it does change within that 30 seconds, if I'm serving something that's 15 seconds old, it's really not going to hurt anybody, right? There's no real major concurrency issues around serving up this particular resource. So the idea is your application, all you have to do is set the cache headers. You don't have to worry about caching, actually implementing the caching infrastructure yourself. You use some piece of middleware that further downstream is going to look at those caching headers and do whatever needs to be done. And we send it all the way down to, so there's either a cache at the app side or a cache at the client side, and it looks at those caching headers and does what it needs to do. When it comes to your actual client application, it doesn't have to do anything. It literally just says, I'm going to make an HTTP request for this. You don't need to build this repository layer on the client side where you look up in your dictionary of cache things beforehand. You just say, I'm going to make the HTTP request. It looks like it goes out across the wire, but an intermediary intercepts it, interprets the resource that you're looking for, it looks into its cache, follows the standard HTTP rules, which are all defined in RFC 7234 or 35. I think it's 34. I get mixed up between the caching and the authentication RFC. And it actually will return that back. As far as your client application is concerned, there's no difference as to whether it's making a network request or whether it's getting it locally. So it becomes completely transparent on that side. Whether caching exists or not on the server side makes no difference. You just set the caching headers and hope that there's a caching intermediary there. The nice thing about that, I say hope, but it means that if you're having debugging issues with your application, you can pull that cache out, right? And then continue working and seeing if the problem goes away. You can put it back in and it will continue working and nothing changes. This is supposed to be the beauty of intermediaries, is it allows you to remove chunks of your application infrastructure in order to be able to debug and trace down individual problems. So the key thing is HTTP caching is a well-defined standard, and it has all kinds of clever things insofar as clients can say, no, I don't want to have a cache thing. Please, I insist that it's not cached. They can say, oh, well, give it, I can take it from the cache, but could you check with the server before you give it to me that it is actually up to date? You can say, I don't mind it being cached. I don't even mind it being stale a little bit, as long as it's not stale for more than this amount of time. Or you can say, I don't care, I'll take it stale no matter what. You can even say, only give it to me if it's in the cache. All of these kind of headers have been standardized and have been implemented in many, many HTTP caches, so we don't have to reinvent it and do it wrong all over again. So I hopefully we'll see more guidance and more articles and stuff. I know James Higginbottom mentioned that he's working on an article that has some more caching advice. I know Khalid, and I'm not even going to try and pronounce his second name, but because everybody knows who Khalid is working on HTTP caching type of guidance. So hopefully we'll get more and more uses. And of course, ASP.NET have there in core a response caching module that, although the policies that they've built don't completely conform from what I can see with RFC 7234, it is a replaceable policy, and you can customize those policies to be more spec compliant if you want. The basic flow of it seems to work really, really well. And I have one last little item to add to that whole thing. I saw a conversation just recently, and somebody said, "Yeah, this particular resource, we want to cache it for a long time. It's good to go. It can be cached for, I don't remember what they said, a couple of days, multiple hours, a significant amount of time." So it's great. Create a lot of benefit out of that. But then they said, but when we make a change, we want that to be reflected immediately. So we want an interface to the cache in order to go and update the cache. Now, I know a lot of CDNs do this, and they have these kind of APIs to interface. Now, this is kind of this idea and concept isn't standardized at all in the HTTP caching specification. And generally, the more standard way to do this is to combine caching with conditional requests. So what you would do is, and what they call validators, so e-tags and last modified headers. So what happens is a client makes a request. Actually, hold on a second. I tweeted this earlier today. Let's see if I can share my screen again, and I have a little picture for this. Let's go and find this. Am I going to be able to find it? Dun, dun, dun. This was a little animation that I created for the Pluralsight course that never actually got done. So I decided to dig it out and actually share it. Okay, so let me share the screen now. Somewhere in here, there's a button to share a screen. No idea where it is. There we go. For some reason, Google Hangouts doesn't show a tab in the taskbar. Okay, screen share. Let's see, application window. Maybe we'll try this one and then go over yeah, there we go. hopefully you can see this particular thing. If you can't, if you go to my Twitter account, you'll see this little GIF that I produced. And it shows 3 different scenarios. So the first scenario is the user agent making a request that goes through a private cache to an origin server. And the origin server returns back and says, here you go, here's this resource that is good for 5 seconds. Oh, and by the way, I'm going to put an identifier on this very specific representation. It's kind of like a checksum to say, this is exactly the data that is in this representation. We store it in the private cache, we return it back to the user agent. The user agent makes another request within that 5 seconds. The response is still fresh, it immediately gets it back, no problem. But then what happens if all of a sudden that request, that at 5 seconds expires, the response, the cached representation becomes stale, and the user agent makes another request? Well, he makes the request, and the private cache can say, well, I have this, but it's stale, but it has an e-tag. So what that means is the private cache can actually forward the request onto the backend and add an if non-matched conditional header. And it passes that request onto the origin server, and the origin server says, oh, okay, he's made a request for this representation. I will go and generate the new representation and compare the e-tag of the new representation with the one that the private cache says it already has. It says, hey, it hasn't changed since then, so I'm going to return a 304 response, and the private cache is going to go, oh, it hasn't been modified. It can actually update that stored representation to now be fresh and return it back to the user agent. So although we did make the round trip to the back end, we didn't actually have to return the representation. And in theory, if the origin server is clever about the way it tracks e-tags, the origin server might not have to do the work to actually recalculate the representation. If it can determine what the e-tag is without regenerating the representation, then it can reduce the work there. So to go back to the scenario where the person, they wanted something to have a long cache lifetime but be updated almost immediately, is what you can do is you can set a fairly low max age. So you can say, look, you can ping me every 30 seconds to see whether it's changed, but we're going to use conditional requests so that I only have to send you a new one when it does actually change. So that means that there will still be a slight delay in when the client sees the updated resource, but it doesn't mean that we are not continuously sending an updated representation across the wire. So that's kind of the standard way of handling that. I'm not saying there's anything specifically wrong with hitting a cache API in order to invalidate something and force a new representation to be returned, but it does require you to there's no standard interface to that, so it depends on what cache you're using, whether or not that capability is available, and you have to couple yourself to that third-party caching implementation. Okay, that's mostly what I wanted to cover with regards to HTTP caching. Which brings me to the final topic. And see, I can get through the topics in half the time if I'm just talking on my own and Glenn's not here. Not saying that that's a good thing, but there you go. So the last item was entitled, What JSON Schema Isn't and Why That Might Be a Good Thing. And this kind of reflects a change in perspective for myself that's sort of growing, and it comes back to a lot of the experience that I've had working with OpenAPI over the last couple of years, because OpenAPI uses what we like to call a super subset of JSON schema. We use JSON schema with some other stuff that we've invented, and we don't support all the capabilities in JSON schema. We support more of it in version 3. Version 2 was quite limited in what we supported. And the problem that we run into regularly is people look at JSON schema as a way of describing the payloads that they send to the server and that they return back from the server. And this data is used for numerous purposes. It's used to generate documentation, generate and show examples to people, and it's also used for generating of clients on the client side. Whether you think that's a good idea or not is a whole different topic, but it basically is trying to use JSON schema as a way of modeling those representation shapes, saying what properties exist in them, what objects, how they're contained, what the constraints are, whether something is required or not required, these kind of things. And the problem they run into is JSON schema is not very good at modeling objects, hierarchies, document structures. Now the question is, well, why wouldn't it be good? Isn't that what it's for? Well, that's the problem. No, it's not. JSON schema was always designed as a way of validating payloads. It's all about saying, does this property exist? And if this property exists, does it meet these criteria? You can define a schema in JSON schema where there's no type specified. You can define a schema and say, well, it could be this type or that type or this type or this type. You can say, well, it might be an array. If it's an array, it has these schemas, and if it has properties, it would have these properties, right? These are things that you physically can't do in like statically typed languages and classes. So you can describe things that just aren't possible, and in the same, that just aren't possible in language class modeling. I mean, maybe they are in some esoteric languages that I'm not familiar with, or maybe some very clever languages that I'm not familiar with. But in the mainstream languages, JSON schema can do lots of things you can't do in the languages, and also on the reverse, there are things in languages that you can't do very easily in JSON schema. One of those being modeling inheritance hierarchies. And folks really like their two things. They like inheritance hierarchies, and they like payloads with wrappers, where you have some kind of common set of attributes around your actual data. So it's like, well, we don't really want to use HTTP headers for the metadata. We want it in the body. So we're going to create this wrapper shape that's consistent across all these different resources, and then have special stuff specific to this particular resource inside there. And JSON schema is really not very good at doing that. You can sort of do it with one of the JSON schema operators called all of. And what all of is an array of schemas. And people look at it and think, well, okay, it means that I want to merge these schemas together. But that's not how JSON schema processors work. JSON schema processors say, oh, you have an all of. Well, I'll first validate against the first schema, and then I'll validate against the second schema, and then I'll validate against the third schema. And if it passes all of them, that's fine. And that works because JSON schema by default is very permissive insofar as it only validates what it recognizes. If it sees something it doesn't recognize, then it doesn't do anything with it. So you can incrementally validate a payload using a set of independent schema objects. It means that you can't then all of a sudden go and attach the additional properties false and actually bound the payload to not allow additional properties in there, because then all hell breaks loose, because you need one schema that has additional properties equals false to describe everything. But I digress. So all of sort of works, and by using $ref to be able to ref common schemas, then you can sort of get around that. And my thoughts around this so far have largely been around, well, yes, JSON schema isn't very good at modeling, and people want to model payloads and they want to model inheritance hierarchies, and maybe we need something better than JSON schema to be able to do it, because JSON schema isn't designed to model. And then I started thinking, well, maybe the problem is we're trying to model it. Maybe we shouldn't be trying to model the representations. Or if we are trying to model representations, maybe we shouldn't be doing inheritance hierarchies in representations, and maybe we shouldn't be trying to do wrappers. I mean, wrappers are a classic example of you're making your life really hard to be able to attach a sort of a set of standard common attributes to some other object. You want to return a customer and a supplier object, and you have some common attributes that you want to add to both. So people say, well, let's create a base class and put some common properties in there. Well, how about we don't? How about I mean, there has been a lot of experience in the last 20, 30 years saying inheritance is not really the best way of doing reuse, and composition, aggregation and composition is a better way. And maybe that is a better way also for modeling our HTTP representations, in that we have a customer object, and if you want to attach common metadata to it, then put a child object inside that customer object and give it a particular name. Much like we do with interfaces in programming languages, where we say this class implements iFoo. Well, let's create a foo object and add it into our customer object. And we can add it into the supplier object. The nice thing about that is when we come along later and we want to add some additional metadata that is common, we want to add an auditing object. Well, we'll add an auditing object to this one and this one. It doesn't matter that it already has a foo object. You know, we don't run into the, oh, well, you can't derive from two base classes problem, because we can keep aggregating in additional things. And JSON schema is perfectly fine at being able to describe that. A client application should be perfectly capable of going, well, does this customer object contain the auditing object? If it does, then let's use this generic auditing code in order to get our polymorphic type behavior here. So we can achieve a lot of what people are trying to achieve if we stop using inheritance as a way of modeling our types that we want to send over the wire. So that's my little rant for today. And maybe the constraints of JSON schema are not really as bad as we think they are. Maybe they're just stopping us from doing things that we really shouldn't be doing in the first place. So with that, I am going to just take a quick look at Twitter to see whether anybody has posted. No, nobody's posted any questions. Well, we'll be hopeful and assume everybody will watch this once it's recorded, and everybody's busy working at the moment, so they should be. Now, Seb did ask what happened to linked cache invalidation. Which is an excellent question. So just to give a little bit of history, this was a draft of a specification that was put together by Mike Kelly of HAL fame and Mark Nottingham, who's now the HTTP Working Group Chair, back in 2010. And the idea was that you could define they defined link relation types that you could put in a link header that you could return from a server, and the server, you would return from a server, and then intermediary caches would use those link headers in order to invalidate resources in caches. Yes, I believe that's. I don't know whether you know what, I do remember seeing something about one of the major caches actually implementing it. I don't know. I mean, it was wouldn't surprise me if Akamai, because Mark was working at Akamai at the time, so it wouldn't surprise me if Akamai actually have implemented that. Wouldn't all surprise me if Fastly implemented it, which is where Mark is working now. But it's definitely worth looking into, because that would be a standardized way of invalidating caches. It does sort of depend on somebody making another request. So you couldn't preemptive. Well, yeah, I suppose there's ways of using it to force caches. You just make some request to the API from the API in order to cause it to be invalid. But yep, it's an interesting way of having a standard approach for invalidating caches. And so I have run out of topics. It's been 36 minutes. I've been blathering here on my own to myself. So hopefully we will do a better job of scheduling. And next week, Glenn, not next week. We do this bi-weekly because we have hard enough time coordinating between ourselves to do this weekly. So hopefully you can join us in the next 2 weeks. And in the meanwhile, if you have any questions or topics that you are interested and in talking about, then feel free to post on our Twitter feed. Thanks very much for joining us, and we'll see you next time.